Welcome to the Novel Podcast. Today, we're delighted to be joined by someone who's something of a legend in industrial design, certainly in the Northwest. A multi-award-winning designer, engineer and entrepreneur. As well as being a talented musician, he's also become a mentor and vocal advocate for the value of good product design and a supporter of the SME community. An alumnus of Newcastle University, Imperial College and the prestigious Royal College of Art. He's worked for the British government and British government's innovation agencies, as well as UK Design Council, and has mentored dozens of young designers and startups. On a career that spanned over 30 years, he's worked at the forefront of user-centric design and has an enviable portfolio of successful projects, particularly in the medical and scientific device space. Welcome to the table, Jonathan Butters.
Thank you very much, Andy.
I'd like to jump in at the middle. What's the state of British design right now?
Interesting question. It's changed a lot since I got into the profession. Obviously, things are very digital these days. Things are very fast. I think the state of design, as I see it, is very good. I think we're beginning to get traction on environmental issues, certainly user-centered issues. We're getting better and also being facilitated to address societal needs and to understand that large percentages of the population haven't been well served in the past. Classic example is women. I think the world's first crash test dummy that had female anatomy was 3 years ago.
Wow.
Partly because the regulatory framework says that you have to use a male model in a crash test. But maybe there wasn't the will in the industry that's quite male-dominated to actually make the change. So I think we're in a very healthy space in that way. I think it's been recognised, certainly through the facilitation agencies that help designers get the leverage, because in the end, we're generally working for clients. If the client doesn't want you to do something, it's very hard to do it. But because funding has come into women in innovation and also women's health, we're seeing that designers are now being permitted to actually be more inclusive in their design solutions. That's where I see the really positive side of it. Our manufacturing base is still strong. It doesn't employ as many people as it used to, but it's very highly technological, very highly automated. AI is coming into manufacturing in a big way, but it still has the human intervention within that.
That manufacturing piece, as we're seeing kind of more kind of quality, high value manufacturing, and as you say, we've got more automation.
Yeah.
Those apprentices that are on the tools, they're starting to use CAD more. Is that changing the dynamic for your design for manufacture?
Absolutely.
Or is that
yes.
you're seeing
There's a certain upskilling, but there is still a requirement for people to oversee. If you go and see a very highly spec state of the art manufacturing station, multi-axis, there's usually somebody who's got the job title of machine operator that's keeping an eye on it.
Yeah.
It doesn't matter how many sensors it has in it; these things break down, and sometimes you need those eyes on because the program wasn't quite right, and it's not quite making what you think it's making. And I think the best relationship with technology is that it's an extension, it's a tool for humans, and humans are there as the moderators and are very much guiding it, because humans are very good in looking out of the windscreen of the car and seeing what's coming, whereas machine learning and AI systems, etc., have been designed using a rear view mirror. In other words, they're based on historic. They might be able to synthesize where that might go, but I think humans are very good at saying, no, this isn't the direction we need to travel, and pulling things back in line. So I do think that the human element in design is very important, and that's where I think the UK has excelled in developing youngsters coming into the profession who are very creative, very inquisitive, And, employers are now understanding that, I think. And if you look at most challenges within business, they usually include you have to be more innovative. And that's where the talent comes in.
So you're a mechanical engineer by first discipline. So thinking about those modern manufacturing plants, are we closing the loop or accelerating the loop on kind of design and feedback from production and the user-centric bit? Do you think that's a new world you're entering, a kind of more efficient process?
Yes.
Where designers and production managers and production engineers are getting it right earlier?
I think the general answer is yes. In specifics, when I started in engineering in 1978, I'm officially now a designosaur. The company I worked for, they had digital readouts on their machines. They had robotic welding. They had machines that would track and follow profiles on paper using an optic sensor.
Yep.
We had a CAD system. This was in 1978 that designed pipe work for chemical plants. Yes, it just drew the center line of a pipe and gave it a color that represented the diameter of the pipe. And yes, we did then get a model maker to make a scale model physically of the plant, but we were using CAD in the 1970s. The technologies as they emerged have been adopted by different sectors. The automotive industry was particularly fast at adopting additive manufacturing and rapid prototyping and the sort of support technologies around that. In the 1990s, I was seeing actual finished products going onto vehicles. I think Bentley were making headlamp clusters, which started as 3D prints, went into vacuum casting, and they're metallizing, and they were actually going into vehicles because they weren't making enough vehicles to justify the tooling. So the finished car actually had parts in it that had come out of what we would used to called a model making studio, and that was being adopted in the 90s. I think the first 3D metal printed part I commissioned was in the early noughties.
Wow.
We were using there was a centre in Liverpool, the Product Innovation and Development Centre at Liverpool University. They were very early adopters of 3D printing technology. It was primarily SLA technology that uses a liquid resin and cures it with ultraviolet laser scanning.
It's Chris Sutcliffe now.
Yeah,
no, Chris.
The parts didn't have a lot of strength, but they were very accurate. And then you can make a mold from them. They also innovated. There was a guy called Chris Sutcliffe who was one of the leaders in metal laser sintering, and I think he then worked or helped companies like Renishaw to develop their 3D metal printing technology, some of which went into medical implants. Stryker, I think, made hips. But this was in the noughties. Wow. So my industry has seen these technologies for a long time. They're fairly ubiquitous.
Is that frustrating? Because as a designer and at that concept stage and as a technologist and a futurist, it's 20 years. It must be frustrating to why does it take so long to mature? Why does it take so long to democratize?
It takes a while because the technologies are very, very expensive to start with. The entry level is prohibitive, but also you need a whole cluster of skills around them. I've got a desktop 3D printer. Saved a bit of money by assembling it myself, but it's really, it's a real workhorse. It will do something, about 200 mil by 200 mil by 250 mil, that sort of size. But if you build diagonally, you can make bigger parts. So these have been in schools for a decade. A lot of schools in their design technology department have, again, we're allowed to have 3D printers that, the youngsters get a bit of experience on. So I think that's where we've seen the translation, because we've actually seen, youngsters in schools get familiar with this stuff, and then, you could buy one of these machines online for a few £100.
Yeah.
And they're quite impressive. Just watching them, it's almost as good as mowing the lawn or watching
Cathartic.
a washing machine and spin cycle. It's just watching them go backwards and forwards, like creating this thing, like a wasp making a nest. It's the same technology, really.
Yeah.
And I think that they're really friendly bits of technology. But what you do before you do the design process, the CAD, the 3D printing, that's why you see a lot of people 3D printing at home chess pieces or characters, because they've downloaded the CAD file. They haven't really done a lot with it.
Yeah.
And they're just building something that they've just brought in. It's effectively like 3D clip art. Where the real power of that machine is at the design stage and creating a CAD model and then building it. So I can guarantee that most of the things that get broken in my house, I replace them with 3D printed parts, because it's probably cheaper and quicker than trying to get the spares online.
Interesting. Going back to your observations about kind of female crash test dummies and the legislative environment, do we need more designers in the legislation process? Because when we've talked at VEC about design for regulation, and particularly with things like digital twins and AI models, the regulators are not keeping up with the technology and with the real world. So how do you get regulators to see design as an integral part and as experts, as opposed to somebody that
regulation generally trails behind innovation. I'm not sure which part of the world does it better. There is a culture, I think, in the UK of waiting until something's a problem before fixing it. For example, you get lots of e-scooters on the road before they start thinking, how can we handle that? You can buy them, but you're not really allowed to use them legally. But why can you buy them? It's these sort of things. Drones. I mean, I used to fly model airplanes in the 1970s, radio controlled.
In the park?
Yeah. Well, actually at a proper plate, because you had to have a license from the post office. You couldn't operate a radio controlled boat, car or plane without a license. And you had to work within prescribed broadcast band frequencies.
This was GPO kind of spectrum.
It's back in the day when they controlled radio broadcasts, because they didn't want you to interfere
with the TV
with other bandwidth. So you're given a very narrow bandwidth, and you had to have a license to operate. Like you had to have a license to fish, you had to have a license for a dog. I don't understand how we moved into drones and not having to have a license for them, because they can be harmful, they can be antisocial. They can cause, as we saw, problems at airports. They're a very good way to get drugs and mobile phones into prisons. But the whole process of licensing or requiring technology to be at least moderated in its use, we don't seem to do that, or we don't police it, which is quite interesting. But I think that's an example where regulation, it sort of seems to trail behind innovation. The other thing that I find very interesting is, because we do have legislation, inclusivity and diversity, and yet you look at the way we fund medical research, and I haven't got a source for this, this might be anecdotal, but I think only 5% of funding for medical research in the UK is specifically for women's health.
Right. This is NIHR, EBSRC,
everything,
Medical
and
Research Council.
VC investment, the whole lot. One of the issues is that clinical trials are more expensive to do on women.
Why?
Because women have reproductive they have a womb to start with. So the insurance is more expensive to insure a trial on women because you could be impacting on an unborn baby, or
So the sponsor of the clinical trial is less interested.
Yep.
They want to start with a simple
Exactly.
sample, clean answer, drug to market, and then we'll sort it.
They usually start with men. It's not always the case. I mean, women do take part in trials, but there is this issue. That is a barrier. There is a cost issue. But there's also, I think, a practice where most medical technologies are developed for men and then translated for women. Now, if you think of motor vehicles, when there wasn't a crash test dummy available until 3 years ago, you have the scenario where you actually have solutions that are developed which may potentially be harmful. Women's anatomy is different, their joint strength is different, their bone density is different, stature and demographics are different. And then plus you have the fact that if a woman's pregnant or etc., those are components which are not addressed. So if you look at the historical development of seatbelts, in certain circumstances they can be quite damaging to women, but not to men because they haven't been developed. The actual ergonomics of a vehicle are designed around men. All the crash testing that was done before they had the female anatomy model was done with a male teenage dummy.
So they knew
which
there was a difference in
a
size
woman.
and mass. So they just...
But it didn't have sensors and anatomical finesse that would give you the data that would relate to how a woman's physiology would be impacted on by front, rear, side impact. It's the same with medical. If you develop a treatment on the sort of male model and then you translate it, there's been classic cases of even like looking for the symptoms of heart attack.
Yeah.
Women's symptoms of heart attack are quite different from men.
Really?
But until quite recently, people were advised to look out for the classic signs of, left arm aching, pains in the chest, etc. And women have been harmed in medical pathways because they've been misdiagnosed.
How? I mean, the medical. You've had success in medical device instrumentation. That's a really hard. They're hard yards. That's very regulated, very cautious.
Yeah.
That design thinking approach and the user-centric approaches that take. How do you get that into clinicians? Because clinicians are generally quite conservative, very data-driven. So many kind of medics I speak to, some of the hardest yards they have dealing with patients is sometimes the right answer is to wait. So you'll administer a drug or a condition will be evolving, and the patient and the next of kin want to see something being done, and they say, look, the actual best thing to do is wait for more data before we interact. How do you get those user-centric approaches and design thinking into that very literally clinical data-driven environment? Is that something
I think the best tactic is to create the data, create the evidence, and then you've got the basis of the argument. So I feel within the design process is a process of exclusion. You start off, everything's possible. Then you start to refine things down through specifications and requirements and design inputs, and you end up with a solution. And quite often the solution is a basic version of a more complex solution, because you might go for a minimum viable product. So it's a process of exclusion. Good designers understand what they're excluding. Otherwise, it's an accident, And like I said earlier on in our chat about disability, disabilities are often a result of a situation. So it's not the person. You've put them in a situation where they can't get into a building because you put steps in front of it, It wouldn't have been an issue if you had thought that through. So you've excluded that person from the solution. The same thing happens in all design projects. You do have to decide who you're dealing with. With medical devices, it's absolutely important to define the user requirements. Who are the stakeholders? Who's going to benefit? And all the classic business terms like where's the pain point, etc., and what are going to be the economics. Where is the market? Where are the majority of beneficiaries going to be in this solution? You really need to define that early on. I've worked with quite a lot of clinicians on medical devices, and they're usually very open to those sort of discussions. What you mustn't do is hard bake into the design process exclusions that should have been included. Yeah. And that's where the sort of critical friend element comes in. Designers are often critical friends. We like to write the brief. Yeah, we don't like to be given a brief, because as soon as you give us a brief, we're still in touch with our inner toddler, and we'll go, why?
So you want the problem, you just want to start with the problem, you'll quantify the brief, and then you'll go back to the client.
Sometimes we'll question the problem.
Right.
I mean, it's another famous sort of innovation business tool, the 5 whys. You just keep asking why, because the first answer may not actually be precise enough to give you the answer that you need. It's the same in when we're doing user-centric work. And, you know, medical device development is interesting because there's a term used, particularly by tech developers, a term called agile, which is just rush into it, you know,
move fast, break stuff, go back into the cycle.
Stuff, or fail fast, fail cheap. And we'd like to, and obviously we user-centered design, we'd ideally like to go and stick things into people's bodies and, you know, attach things and go into hospitals. You can't do it. Ethics get in the way. And the whole ethical side and regulatory and patient safety is a big issue in medical device development, because I would want to go and do very early stage design verification. So we might be prototyping part of a design. And then we want to test it. If you can't get to the end user to test it, it's very difficult to verify. So it's important to understand that there are ways around this. Obviously, university teaching hospitals are very good because they can indemnify and you can get access. I mean, we've worked with charities that work with people with neurological conditions, whether it's stroke, whether it's other conditions, and they've introduced us to their stakeholders and their user team. So we've gone in through that, and we've shown early stage prototypes and even designed them so they could wear them and try them and give us feedback before we really spend a lot of money. So you can do it. I've worked with clients who are developing invasive devices, surgical devices that you would actually insert into a radial artery in your wrist, right through into your central circulatory system and into your heart. And we've developed access devices that enable these catheters to get round tortuous pathways within your arteries or get past blockages. And we've developed that very much with the surgeons who have been there. You know, they've been in the catheter lab with a patient in discomfort on the table, having a spasm in their arm, and they have a very narrow window of opportunity to do their intervention. Right. So as a designer, I need to put my clients' shoes on and walk around in them. You know, so I've been in cath labs. I've actually met patients who've been through that particular procedure. I've met the cath lab support team, the nurses, those who do pre-op and post-op. And it's really important to have those conversations. And I think we can then address your question as to how do you work with clinicians to be more user-centered. They actually really want to be. But it's a way of building up a sort of evidence trail that allows them to make those decisions.
So we've got clinical scientists, clinical engineers.
Yep.
Are there clinical designers? And if there
Yeah.
aren't, do they live in the NHS? Should they live in the private sector?
Medical designers? No. I had a series of internships recently. These were young women who had got really good grades at university. You know, they had mechanical engineering or other related technology degrees. And the NHS was effectively paying them to train as medical engineers. Mm-hmm. And at the same time, they were funded to do a master's degree that specialised in medical
Yeah.
engineering. So they were being introduced. If I roll back, when I did my mechanical engineering degree at Newcastle University, we did steam engines, we did all that sort of stuff. It was very good and solid, my final year, one of my final year honours subjects was bioengineering.
Okay.
And it was fascinating. I chose that because I thought, I don't know anything about bioengineering. That's why I chose it. I'm an inquisitive person. And what we had a couple of doctors come in every week. They would bring bits of body in with them. We're talking about, half a leg wrapped in formaldehyde cloth. And they'd show you how the anatomy works. And then we'd talk about how would you design artificial hips. So we would look at the biomechanics. We would understand, the free body diagrams, the forces, the accelerations. And you could then lead into understanding how you attach a rigid piece of, as it was in those days, machined stainless steel, cast, forged, machined, into a bone, which is living bone.
Yeah.
How do you prevent the bone from dying? How do you keep the load in there? How do you ensure that the hip moves in the same way that the person's hip moves? So we were doing that in my mechanical engineering degree. We also did artificial kidneys. We understood kidney dialysis and
filtration technology.
Yeah. Osmosis,
Right.
semi-permeable membranes, and we had to learn a little bit of Latin so that we understand the medical terms. We looked at diagrams of anatomy, and as I said, and it was just before lunch, so we were always a bit squeamish. So they would literally bring body parts in and talk about them and say, how do we synthesize this as an engineering solution? So it was fluid dynamics, it was materials, it was mechanics. So that really opened my eyes. I didn't apply it at all until later on. Probably 20 years later, I started applying that in my career, which has been all over the place.
So you talked about some of the kind of the emerging opportunities, so sustainability, sort of sustainable transport, energy challenges, and I guess aging population as well. So what are the challenges for the design industry in rapidly kind of getting us solutions?
Well, designers love constraints, but those constraints move. That's why things can always be improved. And we've got a lot of drivers, and we always have done, to be honest. Obviously, energy is a big issue. Materials. We are now starting to actually put into practice circular economy and total life cycle analysis. That was something that you would study in college in the 1980s and never find a client who was interested.
Who'd pay for it?
Now, yes, it's very much coming in. I must say, it was about 15 years ago I went to the Institute of Chemical Engineers in London because there was a very interesting seminar which I wanted to attend. Just out of curiosity, we had the head of research and development of Ford Motor Company from the States came over, and he was talking about the development of motor vehicles at the time. At this point, no one was talking about electric vehicles. The technology wasn't mature enough, even though there were electric vehicles in the 19th century. But anyway, he was talking about lightweighting of vehicles so that they use less fuel to travel because they were carrying less weight. But he had a very for somebody senior to a company, he had a very interesting spin of it because he said, this is just a marketing ploy. It's greenwashing. He didn't use the phrase because that wasn't a phrase that we used then. He was saying that the materials we're replacing steel with, polymers, composites, have a far worse environmental impact. So when you looked at the total life cycle of the vehicle, we're making them worse. But they will use less fuel during the operating period of that vehicle. But in terms of the manufacturing stage and then afterlife, whether it's recycling, whether it's landfill. He said we're making the problems worse. And that was fascinating. That was over 15 years ago.
It turned out to be absolutely correct.
Yeah.
There's composite materials.
And he was
resins are
knowing,
more
he was in a
difficult to break
company
down.
that was knowingly doing it.
Interesting. And that's where the regulators also don't keep up, even down to expressions like, you know, your carbon footprint was a way to move the responsibility from the big corporations to private individuals.
I think we do have these metrics now where we are looking at total life cycle. There's loads of, these are all drivers to design. These are all new constraints to work within. So I think, you know, obviously the user-centered side of it, there's a lot of failure in innovation because the stakeholders and users were just not brought into the process until maybe the end, where they're just given limited choice. Technologies are moving on all the time. Design for robotic assembly, you often have to roll back and redesign the product if it's going to be assembled correctly. If you then have, you know, and these are all different things on the dashboard. You know, 30 years ago, you may not have been worried about the material choice in terms of what happens next. We're very much conscious of that now with microplastics and what happens during and after use. And this total life cycle approach, I think, is very healthy, and it's becoming more mainstream. One example that I think hasn't been tackled is refrigeration. It's generally running 24/7 using huge amounts. I think a third of the UK electricity generation goes into refrigeration. Wow. We lose a third of electricity through transmission. The rest of it does everything else. Now, those are figures I was given about 10 years ago. So you can correct me on that and do a fact check. But the point is that if refrigeration is sold as a commodity product, in other words, a capital investment, it will always be the lowest cost technology, which will be a balance between its efficiency and what it costs to buy. If refrigeration was delivered as a service, I just want a cold space to put my food or whatever, like a mobile phone, then we'd see innovation actually in the core technology. So we'd see sort of satellite cooling technologies being used. We would see, you know, Stirling cycles and other technologies which have never been rolled out in the mainstream because they're very expensive. But if you look at the majority of cost of refrigeration is its energy use in its lifetime, and that's getting higher and higher and higher. Imagine if you effectively just rented your cool space or your appliance like we used to do. You remember back in the 70s when you used to rent your telly from Rediffusion, and because tellies were not reliable, and they'd always come and fix it or replace it if it broke down, because people didn't want to commit to buying a television because they didn't know whether it would be working in a year's time.
And you'd need to,
Well, I think refrigeration could be sold like that. So instead of going to your local domestic appliance manufacturer and buying a fridge, you effectively have a service provider that delivers a fridge, and you pay for it through the energy use. So the fridge might be a £700 fridge, whereas if you bought it from the shop, you would have only bought a £200 fridge because you think £700 expensive.
It's a utility model.
But the utility model, you know. Now, we might be moving that way, but these sort of rewiring of markets can impact heavily on the actual design of the product, because to design a product to fit that model is quite different than something that you just go and buy and own.
I guess that I mean, I'd be interested in your take as a designer on your observations about, you know, the inefficiencies in electrical grid and the distribution kind of overhead. Community grid or demand side power
Local
generation,
stuff.
solar, battery bank.
Yeah.
If I'm generating more than need, then I've just got the washing machine on, can borrow it. That changes sort of social practices as well.
Yeah.
That could build communities. That could give you visibility of, okay, who's generating, when do we use it?
And I think that's powerful. I think it's empowering. Obviously, being one of the awkward squad, I'd first of all say use less. But in the usual sort of consumerist model, it's very difficult to sell less. So most models implicitly encourage us to use more. So what you see is green generation is just an addition, because the demand keeps increasing. So it hasn't really replaced.
Right.
It's just the cream on the top. There's a very good book that I've read recently, which is all about degrowth. It's called Less is More, written by Simon Hickel, I think. I got his first name wrong. And he talks about rewiring the way consumerism works, and rewarding good behavior, having less rewarded rather than more. Because if you can't have infinite growth. If our fundamental consumer models are based on more extraction of materials, more exploitation of labour, you actually run out in the end. And you can't replace all of that with more machines because you've run out of raw materials. So there are different models, and some of them actually need rewiring of economies and wealth redistribution, etc. So you get quite political. It's hard not to be political because I think all technologies are value laden. There is a political element to products, how they're used, how they're bought, how they're disposed of. They all fit within regulatory frameworks. They all can empower and bring quality of life. But we've got to understand there can be a trade-off, there can be a downside. And for me as a designer who's now, as I say, I'm now a designosaur because I've been doing it a very long time, you get a chance to reflect. And I think a breakthrough in my thinking was when I worked at Liverpool John Moores University, because I was an academic for 10 years. My colleague, a guy called Martin Downey, and he talked about reflective practitioners. And that phrase stuck with me because it means really think about what you're doing. You might not be empowered to deploy that in the work you're doing, but be conscious of it.
You will create the tools that somebody else could have unintended consequences or second-order effects that you don't.
Yes, and you may actually be empowered later on to implement and bring it in. And I think we're seeing that because I think there is a change in terms of energy and environmental use and materials and afterlife of products and landfill and reuse and circular economy. These are coming in because of reflective practice, I think. People have made those happen. They don't just happen accidentally.
Do you ever worry as a designer that, sort of going back to the energy analogy, is demand side generation or user generation through solar or wind, does it lead to a disintegration of the system? We went through a phase, industrial revolution, where if you wanted a factory, you'd need to be near a river, or you'd build your own steam power plant, and then we said, okay, the deal is we'll have a national utility grid, we'll generate centrally, and that's the cheapest way. We'll build the roads, we'll build the power plants, we'll build the cables. If there is a dystopian view, I guess, where if we're all individual libertarian agents, is that infrastructure goes away and the most vulnerable sort of suffer or the most powerful benefit. As a designer, do you think of that?
I do. And I think a lot of those either centralization or distributed models were very much a function of the technologies that we used at the time. You can have a very centralized system if you've got huge generation plant, nuclear for your baseline and coal and other ones that you can flex demand, pump storage systems, that model does have to change when you start to distribute the generation. It's obvious it has to change. And I think the societal point of it, I wouldn't say it's like I'm an island sort of libertarian model. I think it's more community based. For example, my house, I've got a big house, but the roof is weird and we've got lots of trees, so I can't put solar panels on it. So I can't generate. But my neighbour might be able to generate more than they can use. You've suddenly got a little ecosystem going on. It has been tried in the UK before, but certainly in Soviet Russia, they had a lot of shared heating systems,
right,
where you might have a local industry or generation capacity that would put hot water out through pipes, and they'd heat entire blocks. The problem comes when that system breaks down, and then everyone loses their heating.
Yeah.
So models need to be resilient. We've also got higher incidence of storms. Solar panels are quite vulnerable.
To being ripped off roofs in strong winds.
Yeah, exactly. Which is funny because I've got another side hustle.
Don't tell me you're a roofer as well as a designer.
I have been a roofer. In fact, Charlotte, my super spouse, we've roofed a cottage in Wales with antique slates. So yes, I have been a roofer, and it has actually got brackets for solar panels to go on. But in exposed areas, coastal, island, hilltop, high storm events can be really damaging to solar, because it's not the wind per se, it's the debris that's being carried. If you look at any of the big storm events they have in the Caribbean, it's absolute devastation. It doesn't matter if you had a solar panel attached to your roof's not there anymore. So what we've been looking at is resilient solar, basically panels which can be retracted into a housing when there's a storm event and then redeployed afterwards. They might be mounted on the ridge of a building, which is usually the strongest part of the building. So even if the roof is lost, there will be repairs required, but you could deploy the expensive solar array quite quickly. It may be it will survive. You could have community level solar generation with panels which might be shade over the car park or over communal space, but you could retract it like they do in Switzerland to mitigate against heavy snow loading on solar panels. They've already got retractable arrays. Well, put that in a community where they've got storms coming, and then you could keep the emergency power grid working for that local community to power the mobile phone network to help with recovery. These are things I think are really good design challenges,
As you talk about retractable solar panels, I've just got the Stingray theme tune in my head and the idea of Marineville kind of going underground.
Well, you know where we come from, don't you?
So your path into design, what was you were from a family of designers, family of engineers? How did you start your journey into
No,
design?
not really. I was the first member of my family to go to university. My great grandfather on my dad's side was poor labourer, signed up actually to join the army before the First World War started. He was that poor, but then caught TB during his training. Never went. He lived a lot longer than his comrades, who actually went to Passchendaele. His oldest son was my granddad, and he was he basically was a fireman during the Second World War in London. Then he became a gardener. My dad was bright enough to go off to university, but they couldn't afford it, so he didn't go. He was, he scored incredibly well he went to a grammar school, purely from his academic ability, and he actually took his final, certificate a year early, and then had to be held back because he was too young to leave school. My dad was interesting because he tried loads of things. His career trajectory was quite a story, because he went from straight from school to Trinity House, which is the civil service wing that basically looked after all the lighthouses. They were all manned. Yeah. So they had to send out boats with food on and bring, dead lighthouse keepers back. And he worked there, and it's post-war when we were still a massive sea power. He met Winston Churchill, I believe, who used to come and check out because he was very fond of the Admiralty. But the lighthouses were all sort of part of that. My dad worked there. Then he got a job, because it was the 1960s. He got a job at Nestle. They used to call it Nestles in the day. Basically in sales, because every railway station had a dispensing unit for Nestle chocolate bars, which got larger or smaller dependent on the price of chocolate. People didn't realise it. They were still three old pence, but you got more chocolate sometimes than others.
You had shrinkflation even then.
They had loads of moulds,
Right.
and they moulded different sized bars depending on the price of cocoa.
Wow.
Yeah, there's a little factoid for you. And then he moved on to a cornflour company called Brown and Paulson, and they and it was great because their headquarters was called Custard Castle. It was in Esher in Surrey. So he was doing that. And then he got a job up in the northeast of England working for a wool company. So you understand that he went from effectively a working class family, and then he was a sales and marketing director of Payton and Baldwin's, that were a big wool company. That's why I ended up knitting for money.
So being an entrepreneur, the
Yeah.
salesmanship's an important thing. The
Yeah.
tenacity and the resilience is
was
an
very
important thing, as
creative,
well as the
and also, I think he was very careful to understand what he was doing. There was nobody in his family that could really guide him in that direction. He worked it out for himself, and he was directing fashion shoots where they get fashion models to come in and wear new designs of knitwear, and then they'd put that on the front of the knitting pattern. So they'd moved on from selling wool to people's grandmas, which was the model before, through wool shops to knit babies' booties and cardigans, to then suddenly the 70s hit and people are wearing flared knitted trouser suits and, all sorts of stuff. And he was sort of part of that story.
It sounds like it's a big inspiration for you.
Yeah, I would
Big
say
role
so.
model.
In terms of attitude, just giving it a go. My mum was the one that really steered me into engineering because she was working. She met my dad when they were at school, right? So they've been together a long time. But she was working for an engineering company in Teesside called Head Wrightson's. She was working in a training department, and she saw there was a route to university through doing an apprenticeship. I was at grammar school. It was a state grammar school. Nobody knew whether I was going to pass my exams or not because I was a disruptive one, bit ADHD, centre of attention, classic designer. I did very well in my O-levels, I did really well, but I wanted to leave. And one week the school was saying, will you please leave, to sort of, will you please stay? But I'd already made my decision because my mum had introduced me to the idea of being a design engineer. And so I left. I went to a couple of companies and you had to go through an exam to become an apprentice. One of the companies said, you've scored very highly, but we're probably going to close down next year, so I wouldn't come here, which is tragic. Very good old engineering company. The other one, Head Wrightson's, they had an apprentice training school with 100 apprentices, and you spent 6 months in the workshops and 6 months in the drawing office, and then if they wanted you, and there was no guarantee, you then went into the drawing office and working your way up through the departments. We were sent away to further education college, Stockton and Billingham Technical College, I really enjoyed it, and it was actually really good. We did the sort of forerunner of BTEC. It was called Tech in the days, but it was written by the leaders of industry. So what you studied was really relevant to what you were going to come out with. It wasn't quite as changeable then as it is now. The trouble is, if you did that again, there'll be new jobs that you've never heard of by the time you graduated. Anyway, I did well enough to go to university, but my mum put me through that process because she thought you could go to university, get sponsored. If you do it after 3 years, you're a mature student and you get a full grant. So that's how I got into it. Nobody else in my family was doing that. I did have an uncle that worked for Liberty's and Sanderson's, textile design, doing those beautiful paisley patterns that you used to see a lot. I wouldn't be surprised your hanky was designed by him at some point. And I inherited a lot of very nice shirts from him.
How do you? I mean, that journey doesn't sound that dissimilar, or the uncertainty doesn't sound that dissimilar to the uncertainty a lot of young people face now. So we worry about the jobs market and the cost of student loans and everyone being pushed into university.
Yeah.
What advice would you have for people coming up who want to be a designer and know the world's changing? Is how do you we talk a lot about connections is it's skills and aptitude as we hire for. What would your advice be for people who've got no connections and are trying to come up through the ranks?
The same advice I gave to my two daughters, which is make yourself available for opportunities. You don't know what they're going to be. Make yourself available for them. Make sure you have the right attitude. And it's all these transferable skills. Being good at research, being good at mitigating against bias, communicating, listening. Active listening's a great one. I'm very poor at doing active listening because I'm always thinking about the next question I'm going to ask. But it's really being in the moment. Obviously, get some vertical skills, but then be more T-shaped so you can move with those skills between different sectors as they emerge and the opportunities emerge. In the particular examples of my two daughters, I encouraged them. They did really well at sixth form. They got great A-levels. I advised them both to go and do an art and design foundation course, which is quite unusual. It's not like any other foundation course. Art and design foundation courses, which have got a long history, and I think they're almost based on what was done in the Bauhaus before the Second World War by Johannes Ittens used to take the foundation course. You try a bit of everything. You break stuff. You make mistakes. You grow up. You learn about experimentation. We don't know what's going to happen. Just try it, Put an orange in the microwave and make a suit of armour out of the skin. Those types of things. You might learn something. We don't know. And at the same time with art and design foundation courses, often the tutors know what might be the best course or the university for you to go to. And you learn, because you might do a bit of design at school, but you don't understand all the different elements of it or what the job entails or how you would fit. So it gives you a chance to try before you buy. And I think that's really important, particularly now it's very expensive to go to university. I know it's a sort of deferred, the loan, you pay it back later on. So it's a sort of student tax, really. But I would say be very open to that because you don't want to get onto the wrong program, spend a year being unhappy. You've really got to love what you do. And if you don't know what you love doing, try loads of things. Be a bit punk rock about the whole thing. Just do it.
I guess designers, as well as being sort of creative, you've got to be pretty thick-skinned. Is that challenging for young people? Is to have the resilience to be able to take the criticism if you've come up with something and it doesn't quite fit the brief? What have you got any examples of when you completely messed up on a design or the client hated it or you dropped the ball or it turned out not to be the way? How did you recover from that to be able to say, okay,
I've actually got a very thin skin and I take it all very personally and I lose sleep and I weep in the corner. So I obviously do what I can to mitigate. I'm really comfortable taking risks, but I balance it by identifying where the risk is and how might you mitigate it. That's really important. Projects where there were failures, because I've always worked on a team basis, there's very few of the projects I've worked on until very recently that is just me. So sometimes it's the dynamics in the team. I've worked on a project where the customer was very clear that they wanted to maintain the design to reflect their patent.
Okay.
They'd made the classic inventor error of filing the patent before you've done any design work. Because what happens if the designer finds a better way of doing it? Your patent, either you're going to come to market with the second best idea, which isn't great if you're wanting to disrupt the market, or you're going to get into the market, get some traction, and somebody says, oh, there's a better way of doing it, and knock you out the market. So one project which was, I was very clear about that, and I made sure the design team was steered to say, no, unfortunately, we've come up with a better way of doing it, and we've done our best. We've shown the client they don't want it. They want us to revert back to what their patent described, and my designer refused to do it. And he kept turning it round all the time back to what he felt the client needed, but without bringing the client along. We went into dispute with that client. We had delivered what they wanted in the end because I put another designer on it. But I think there was a sort of breakdown in trust because the client felt that we were not listening to them. I was doing my best to be the advocate for the client, and I'd failed because the designer who I employed wasn't actually doing what I wanted. So I felt that I'd failed in communicating that or reinforcing it or just taking it off the guy and giving it to somebody else earlier. So that was very disappointing. There are times where we thought we got an early solution and we convinced the client to go down that route, and then it didn't work. We developed recently a product which was I'll get it out of my bag. Little device here. It goes round your wrist like that. After you've had an intervention into your radial artery, and when you pull the catheter out, you're going to bleed prolifically. So they put a dressing on, then they have to compress it.
Yeah.
So they turn this little knob here, and it compresses that. But there's an issue, and they call it arterial patency. If you overcompress an artery to stop it leaking, it will actually heal over and stop functioning.
Right.
You've got two arteries in your wrist, your radial and your ulnar, and they join in the hand. There's a loop between the two. So you can completely disable one artery and the other one's still working. You've got built-in redundancy. Isn't biology fascinating? This device, so potentially this device could do harm. There is a method for checking that by putting a pulse oximeter on the finger, blocking off the ulnar artery and seeing if you've overcompressed the artery. Because if you can keep flow going, but still stop it leaking, then that's good.
So enough compression to stop the leak, but not so much compression.
Yes,
that
and you can measure that with a pulse oximeter on your finger. But we thought the next generation of this product, we'd put sensors in it. So that
strain gauge or optical.
Well, there were lots of options. We looked at many of them. What we decided was to use the same technology as a pulse oximeter used, which is it's effectively an LED. It sends light into, and then it has a receiver. It looks at the color of the light, and the color of that light reflects the oxygen content in the blood, because blood changes color. It goes redder when it's got more oxygen in it. So we thought we could use that to show flow, because if there was no flow, then it wouldn't pick anything up. But what we found was this technology that I thought was good, and I built a little prototype and it worked. I was going, yeah. So I was going, look. But
this is you tourniqueting your own arm.
Yeah. You do that all the time, you know. Yeah. But what was happening was it was getting flow around the other way, because there's a loop in the hand, and we didn't know this at the time, but it was sensitive enough to actually see the oxygenated blood coming around the other side. So it couldn't tell you whether it was flowing or not. What we needed to use was a Doppler system, which would measure actual flow. We looked at the basic technology. It's far more expensive. So we abandoned that project. And I was really sad because I went through a real happiness bit and then crashed because I thought, it nearly got there. It's so close. But we'd proved it wrong relatively cheaply. You know, it's move fast and break things. So we broke that. And then we had to pivot and do something else.
Is that one of the strengths or one of the advantages of kind of small bespoke design teams or specialists rather than big design offices or big design departments and big corporates?
Yeah, I'll use a jargon term, waterfall. What you tend to find with larger organisations and some of the larger industrial design consultancies, they will very much see the light at the end of the tunnel. So what they'll want to do is a big da-da. They want to design the whole product.
Yeah.
And they'll design bits of it, but they'll neglect some bits because they think, we'll sort that out in the wash. And I've actually seen other design companies work like that when we want to get data. We want to use a version of the product early on to prove whether we can get it to work, because we've got a whole load of other work to do, processing the data, machine learning, bit of AI, and we can't get that data because they're thinking of delivering like an end product to us, whereas we really want, and it was a design of the process, but I think that early stage verification might prove that the technology you're developing is non-viable. Now, if you're in a hierarchical company, failure can be quite scary, because you spent a year bidding for this budget, and you put the team together and you're working on it, and the project is not getting there. And if you don't have a culture of understanding that failure is just information, failure to engineers is a great term. We use failure because we want to understand how things fail. So we have machines that will do non-destructive testing and destructive testing, because we want to prove how things fail. But that can be a real barrier to larger organizations, because people are thinking about career trajectory. You know, am I going to have egg on my face? What's my boss going to say when I say, we can't get it to work, you know? Whereas smaller design companies, because we have a certain expectation there's a good chance it won't work, we're prepared for that, and we manage client expectations. And because the way my company works is we build solution teams. So there's only two people in the company, myself and Charlotte. She's very much the advocate of the end user, user-centric, but she can talk tech. She's originally a software developer. I'm mechanical engineering. And what we do, we wrap around on each project a whole community that will be part of the solution. And the thing is, you can be very flexible then, because we're not using in-house stuff. I had a bigger company in the past. We had 12 staff, and we were buying machines and stuff like this. But what we were doing was we were fitting projects to the team. Whereas what I do now is I grow the team to fit the project. You can't
Scalable.
do that when you've got a whole load of staff, because what do you do with the person in the corner who's not busy at the moment? Do you lay them off, or do you keep them? This is really hard. So we're very lean. Means we're very small. Most of the impact of our projects in conventional terms are in other people's accounts, you know, because we'll be paying subcontractors, or it's the client that gets the main benefit of the product. So their turnover will go up, but we stay really small. But we're very much on the sort of forest floor, operating at that level.
Kind of the value proposition.
Yeah.
That fear of failure is endemic in holding back innovation, I guess.
And I think small is beautiful. And also, when I had a larger company, we used to do student feedback survey. Client feedback surveys. And we say, what did we do wrong? What did we do right? What do you want more of? And pretty much unanimously, they always said they wanted more of me, which was quite flattering, really. But I've been growing the company, and the result of that was they were always getting less of me, because I get more staff and more projects. So I learnt from that, and that's why we've got a very small company. So basically, they probably get far too much of me. But, and that way, I find that's better than being a larger company, because the innovation process, you've got to pivot and change all the time. And obviously, small cars go around corners better.
So, I mean, obviously, you've mentored a lot of people over the years, and you've had a lot of folk who've kind of worked for you and then moved on. What are your lessons as a leader for nurturing talent? For actually kind of.
It's not to be a leader. Be a peer. Collaborate. Flat structure. Everybody is valid. Nobody has a monopoly on good ideas.
What are the big kind of watershed moments of your career, and the ones that have leveled you up or moved you up to the next level?
I've got a short attention span. I'm the television generation. So it's always the most recent one, you know. Your most recent baby's the prettiest one, isn't it? You've got more photographs of them. I was so happy with a project that we did for the Furniture Resource Centre. They're a charity based in Liverpool. Their mission is to alleviate furniture poverty. The CEO, Sean Doran, came to me a few years ago and said, we want to look at the viability of cleaning mattresses and putting them back into use, because they had a company called Bulky Bob's that was picking up large objects from households, and they're getting a lot of mattresses, which were then having to go off to landfill. And I think the numbers vary, but between 4 and 7 million mattresses are being landfilled. So there must be a very big bouncy hill somewhere, because you try and squash a mattress. And so they're being paid to take them by the council because landfill costs were high and they're big objects. So we thought, what's the viability? So I thought, well, okay, I'll put together some work packages and a project plan and cost it. So I presented that one. A year later, I got a phone call. We're ready to progress, because I think they're chewed around the idea. They're taking some advice and they're having some difficulty finding out which direction to go. But they came back to me, and so I put together a solution team. I employed a young engineer who's particularly good at sheet metal work. I had another industrial designer who I used on a freelance basis, who's great at conceptual stuff. And we put together some ideas based on lots of conversations with the client, understanding the problem. And we came up very quickly with 3 configurations of a machine that might process mattresses, because we'd found out that there was a service in America where they'll clean people's mattresses in a van. They just pull up to your house and take them all out. So we needed to translate that. So we did your classic process engineering, because I was actually a process engineer as well as a mechanical engineer back in the day. So suddenly this became useful. And we looked at what stage would the machine intervene and what point would the human operator do manual work. We found the hardest bit at the start is triaging the mattresses to work out which ones can or can't be cleaned, and then treating some of the more stubborn sort of stains and marks. So we felt that'll be a manual front end to this, because they had done a sort of trial setup, and they found that the longest duration in the whole process of cleaning a mattress was drying it afterwards. And so we looked at a machine concept that had a conveyor, a roller conveyor. It's actually a pallet conveyor, about 2 meters wide, powered. And we thought, well, the stages that might work is it goes through manual cleaning first, just to get the worst things up, or to prepare the stains. Like, you know, when you're doing a wash and you put some stuff on to make it come out better. You do that. And then it goes through a steam box that I developed. It was like a superheated steam, high pressure, would effectively surround the mattress as it passed, and then there was a vacuum built into that extracted the steam and some of the water and some of the muck until it exited the steam box. Then it would go into an ozone chamber, because ozone is biocidal and you just generate it from the air, and then it decays very quickly. So it went through, and it will penetrate, because it's a gas, it will get into the materials. And then it will go through a UV array, which I made adjustable for height. It would automatically move depending on the thickness of the mattress. And then it would go through the drying stages. That's how we did it. We built this machine coming out of the pandemic. My super spouse and partner, Charlotte, she was on the spanners helping me assemble it. It was about 12 meters long, and we started putting mattresses through, and it was really good. The client then spent a whole primary research looking at what strategies would suit different constructions of mattresses, different stains. So they had a very good knowledge base. So that machine cleaned thousands of mattresses, and we won a national recycling award.
This is Matilda.
This is
So
Matilda.
Matilda's legend. I mean, this is an award-winning. This is an invention from
This
the
is
ground
it.
up. Yeah.
Yeah, and it's the first in the world, first in class. Then, because the market changed after the pandemic, where hotels, student accommodation, holiday camps, they also wanted mattresses cleaning. So rather than roadside collection of mattresses, they wanted them cleaning. And also mattress shops, where you go and buy a mattress, you've got 100 days to return it if you're not happy. And those were going to landfill as well.
Wow.
Yeah, I know, brand new. So, but they couldn't sell them to anyone because they'd had somebody sleeping on them for up to 100 days. So we got those. So the feedstock changed. And there was a requirement, because they were either going back into use in hotels or whatever. They wanted to make sure that the fire retardancy or flame retardancy was maintained. We found that just through the daily use of a mattress, it loses its flame retardancy. It's a coating on the surface, and it erodes.
Was that known before you guys sort of sampled?
It was known, but nobody was doing anything about it, except in certain situations where people will come in and recoat. But they were mainly it was people who would make stage sets in theatres flameproof would go and maybe go somewhere and spray the curtains. Maybe it was like a hostel where somebody might be at risk of falling asleep, smoking a cigarette or something. There were certain places where you're more likely to have fires. So there were people who went into these places and would regularly recoat mattresses, but it was a manual thing with a garden sprayer. So we found that if we were to sell these mattresses after they'd been cleaned or put them back into hotels, etc., they needed to be maintained to industry standards. So the second phase of the machine was I developed a robotic spray unit and a second drying chamber, because we were putting more moisture into the mattress. That was completed, and we proved it, sending mattresses to the fire testing lab. They passed. And then we won another award, Liverpool City Region Culture and Creativity Award this time, which I thought we'd got no chance of winning. But we won the Innovation Award, and that was earlier this year. So that's the most recent high spot, I would say.
I mean, that's an amazing story. When you reflect on that, a charity that's doing charitable work has led to an entirely new enterprise and entirely new business opportunity.
I know.
What's the carbon saving of what you've, the potential carbon saving of what you've achieved? They're not going to landfill, they're not going to furnace, but that is the environmental.
It's huge. And on Furniture Resource Centre's website, I think the statistics are on there. It's like taking a number of cars off the road for a significant period of time. That's what the benefit is, by not disposing of perfectly serviceable mattresses. I mean, we're doing everything to these mattresses to remove anything that would give anybody a bit of an ick thinking about it. And so, it's got a huge environmental benefit and a social benefit, because some of these mattresses go to people in furniture poverty. There's a lot of people sleeping in houses with no beds. It just seems to be where we are at the moment. And this because they're a charity, I must say we also help them apply for and get Made Smarter funding for the first iteration of the design. And then the second iteration of the design, there was a Liverpool Specific Innovation UK award called the Launchpad MFA. We got nearly 100K for them. Writing the application. So they're a charity. They don't have a lot of money. And it's unusual for Innovate UK to help the third sector in this way for what was a general advanced manufacturing call. But I helped them with that, with the argument. So I think it was a real success on lots of fronts. I like triple bottom line. So yes, it's commercially successful, it's environmentally successful, and it's socially successful.
So on that triple bottom line point, as you say, charity or even a successful business is not going to be good at that public sector grant writing skill.
No.
How do we re-engineer that system so we get best value for money out of it, so that you've
Yeah.
obviously, you're a creative writer, you're a technologist, you're an inventor. What could we do to make sure that we bring more businesses into that kind of support?
I can talk personally. I mean, these are all the transferable skills. You were talking earlier, Andrew, about what advice would you give to youngsters? Being able to write well, being able to be succinct, to understand the question. Because grant writing is exactly that. You've got to understand what their sort of KPIs are, their key performance indicators. You've got to read the overall stuff, do the background reading, basically copy out every question and make sure you answer every point in the question. And even then, the most recent Innovate UK call, there was about a 5% success rate.
It's a lot of overhead and effort for a pretty low success rate.
To the point at the moment, I'm feeling that it's not productive. The last call, which was Design Foundations, unfortunately, there was a huge number of applicants who didn't get it compared to the very small number who did. And I think that's very demotivating, because I've noticed that quite a few design companies over the years have felt the best way to get work is to help the client raise the funding to basically pay them to do the work. They're not charging for grant writing, so it's at risk.
Yeah.
And it's quite a bit. It can be up to 10 days' work to apply for that sort of funding. But it's a really good model, and the way I do it, because I'm actually going to be probably project managing and doing a lot of the work. The work packages are realistic, the milestones are realistic, where we're going to get, everything from the technology readiness level at the start to the end of the project, where the story will be picked up subsequently in terms of commercialization, where the risks are, identifying and mitigating those. Because I've got that level of experience, I can put realistic costings in there and resource requirements for it. So because I think of, cradle to grave, we may only be doing a certain stage of that, but I've got the experience of that whole process because I've done it for lots of projects, whether they're funded or not by public funding, whether they're privately funded, etc. I've done that journey, so I can see where we come from and where we're going to go and what we need to do. So speaking personally, I think I'm a very good person to write the grant, because I would also be realistic in the solution team that we would need. So we might need people in as partners or collaborators or subcontractors, but I would name them in the grant application, and I would have already talked to them and already got, probably top level quotes as to what they would cut. If they can't quote, I would put in a reasonably accurate estimate through experience. And so I think the expectations, the risks, the costs, the resources are realistic through experience. So I think that's a very good way of doing it, where it's being led, because the design process is absolutely key to the innovation process. It's what gives shape and form and human relevance and impact. It's R&D. We see a lot of R, not enough D.
And no design joining them up. There's
No.
okay, I'm
That's what
doing
we
the
do.
research, or there's the problem, or there's the problem I'm trying to solve, or there's the research I'm doing that might have a practical application. But from an academic or from a scientific research point of view, no one sort of steps back and thinks like a designer.
There are great academics. I've worked with them. Generally, and this isn't the case for everyone, because the general case is a general case, and there's always exceptions. But the general case is centres of research is what they're set up for. Very good at research. Centres that teach and train are very good at teaching and training. Those are their USPs. They always have been. They always will be, and that is what they're good at. If they're good at collaborating, then they make great partners. But I find that the needle in the haystack is finding the right person, because innovations are people-based activity.
Contact sports, yeah.
It's not an organizational thing. It's a people-based thing. So I would do the legwork to find if we had a design. And I've had many projects where the DNA is the same. We project manage as a design company. At the points we need it, we will bring in different stakeholders. We may have even spoken to them at the start of the project when we're building the requirements, the design inputs, when we're looking at the design specification as to how we're going to turn those requirements into solutions, the journey we're going to go through. We need to consult the experts. They might become part of the supply chain at the end, or they might be part of the solution chain because we're only doing small volumes of product, but those products have to be very, very close to a finished thing so that we can properly verify them. We may then have to make some major changes in it. So because we've got that experience, we can put those solution teams. So classically, we would engage. I've used Daresbury, the campus technology hub. I was developing a medical device, which was another arterial access device, and we needed to produce a very small, thin, tapered tube. I found out that the campus technology hub had a very, very high resolution 3D printing machine. So it wasn't quite precise enough to make the size we wanted. So we slightly scaled up the design. So we worked at a sort of probably about a 1.2 size. So it was slightly bigger than full size. But because it fitted within a larger catheter, we could try and test nearly every aspect of the design before we put it in a human. The catheter was too big to go into the early stage of your artery, but we could test it. So we did that, and we proved that the concept was viable, which was that was the hard bit. Mm-hmm. And we found somebody who could do it, and it was the Campus Technology Hub. I'm very grateful because the guy that ran the machine was quite happy to do lots of iterations until we got it right.
It's Dave Bogger, Andy.
Oh, yes. It was Dave. And
Master
Andy.
toolmaker.
They're really good. The attitude. It's all about attitude.
It is, yeah.
And willing to try it. They didn't know if it would work. So we got there, and then when we went to the next stage, we then went to a company we found that modified fluoropolymer tubes, and they could make tooling that made a really fine taper on a very, very small tube and a little groove that we could attach a wire to. And then it was all about bonding, so we had to consult with experts in adhesive technology, and even that wasn't good enough. There were no standards to work to as to how strong this thing needed to be. There were no guidelines. So we developed our own specification, and we decided it wasn't strong enough. So then we saw some very, very thin, almost nanotechnology heat shrink tubing, which held the whole thing together, worked fantastically. That product is now heading towards market.
Fantastic. And that's, I guess, what the big consultancies can never do is that agility, that scope in the team for the problem rather than having the big overhead. That's why boutique.
These were little
like
design
yourself,
sprints. Literally, if we get to that stage gate, let's stop the project because we can't do it. But we managed to make progress at each stage, so it was encouraging enough to move to the next stage. The meter was ticking. We had done a quote for this, and we were working very close to our fixed price quote to do this. That was good because there was the funding for that actually came directly from the university, from their research funding, because they were partners in it. But we had a commercial company that gets the product to market who was also a partner, and then we had all of the supply chain and solution chain wrapped around that. So it was complex, but you needed to ask the right questions at the right time to the right people.
Going back to your point about kind of the writing and the bid development bit, is that something that designers need to focus on early in their careers? Is that storytelling bit? We kind of think in terms of STEM and creative arts, but is that being able to tell the story, create a narrative, explain it to different audiences? Is that something we should be focusing on more in teaching young designers and bringing them up?
Yeah, I prefer STEAM to STEM put the arts in there
Yeah.
as well, because that's where the creativity and the innovation comes in. So yes, those skills. We prefer not to. I mean, who wants to sit there writing grants all the time? It's sort of, it's okay, but we'd much rather be getting on making stuff. But we have to do it, and I think we're very well placed to do it. Some can't, some can. But I do think that it's down to communication skills, distilling problem spaces into language that other people can understand. Most designers, I would say, design for people that are not them. I've worked a lot in women's health, in fertility and stuff, and I'm not the candidate for that product, but I have to get into that space to understand it. And I think being able to communicate with people outside of our own niche, to have the correct language, to not use acronyms, to not use jargon is really important. And I think to be able to communicate complex technological and engineering issues to non-technological people, but to bring them in, to have empathy, not to use it as power, but to use it as a way to bring people into the process. Because all we want to do is make things as real as possible, as early as possible, so that, end users and the stakeholders can say, that's lovely, we want that.
That's a great way to frame it, make it as real as possible, as early as possible.
We're always developing what comes next. And if it's a disruptive innovation that has never existed before, you can't just ask people what they want. The Henry Ford thing of, my customers say they just want faster horses. Funnily enough, we are having faster horses now. They're called e-bikes. I've got one.
Two final questions for you is, so the first one, if you could work on any problem with any company in the world, what would the problem be, or what would the company be?
Well, world peace and happiness. I feel like I'm Miss World now.
Something in design, something in
right,
engineering.
okay, fine. Creating a very beautiful low-strength pale ale would be one. 1.3%, because then you don't pay any duty on it. I like making beer. I do make beer. What other things would I like to work on? I think I'm passionate about social benefit and environmental benefit. I'd be very interested to work on refrigeration, on rewiring the model. I'd be very keen to help have an impact of improving provision of women's health in terms of frameworks and products, because I think it's very, very neglected. And I'd also like to see more. I like collaborative design projects. We've got an aging population, so I don't know what company. I don't work for. I'm not a corporate person.
Yeah.
I would always be the outsider. Yeah, like the joker, the village idiot. They're really important. The jester in the court probably was the wisest one there.
Speak some truth.
Yeah.
And for Buses Innovation this year, what are the big projects you've got on that you can tell us about what you're working on? That's really
well, at the
firing you up right
moment,
now?
the big project is about visibility and credibility, because it's actually difficult to get work. So one of the reasons why I was on site at Daresbury today is it's probably the best business networking event in the Northwest, maybe further afield. So we were doing a lot of work, myself and my super spouse, Charlotte, in talking directly to people. So that's the biggest project we've got at the moment, getting work, which sounds a bit odd, but you thought we're useful people who do useful things, but actually hard to do it. Other projects that we've got on at the moment that we want to develop, it's some of it's confidential, but I'm very keen in using robotics in physiotherapy. Again, it's aging population, sedentary population, people who are surviving stroke and trauma. We haven't got enough physiotherapists. That would be a great application for robotics.
Domiciliary care as well?
Yes, and community care,
Yeah.
and just maintaining mobility or improving it. We're working on that. That's something we've got to focus on. I can't say any more, but it's a very exciting space to investigate.
Fantastic. Jonathan, thank you so much for joining us today. Thanks for joining us at the Novel Table.
It's a pleasure.
Thanks.
Stay jazzy.